All right, mathematicians, the last couple days you had an opportunity to try out a fraction circle tool and do some fraction work to kind of get our brains ready for this unit, Unit 5, which is fraction and mixed number computation. So today's lesson, you've kind of already done a little bit. So see if you can figure out what you did in your pictures that matches with what we're doing today, called fraction decomposition. But in order to kind of get our brains ready for fractions again, I want to remind you what it means to have an equivalent fraction, or a fraction that has the same value. There's an example here to remember that we multiply the numerator and the denominator by the same number to get an equivalent fraction. So if we're thinking about an equivalent fraction for 1/5, everybody think, you might be thinking times 2, and times 2 would give us 2/10. For 1/8, could do times 3 and have 3/24. And for 3/4 times 5, we could have 15/20. We of course can come up with lots of different equivalent fractions, but that's just a reminder of how we can have a fraction that has the same value as another one. So our objective today is we can decompose fractions into sums of the fractions with the same denominator. So we won't be using different denominators, just the same denominators. All right. The red circle is the whole, this circle here. And use our fraction circle pieces to show 3/4. What equation can we write to show 3/4 as the sum of the yellow fraction circle pieces? When it's talking about the red circle versus the yellow pieces, those are the tools I'm getting on Everyday Math. So when I open up the eTools in Connect Ed, remember we can get those fraction circles on here as well as our other tool. And when we open it on here, our whole is red and these are our yellow pieces. So that's what they're talking about in this question. But now we're looking at these yellow pieces and thinking, how do we write an equation to show the sum of the three yellow pieces as 3/4? And I know that each one of these yellow pieces is 1/4. If each yellow piece is 1/4, then we can say 1/4 plus 1/4 plus 1/4 equals 3/4. That is an equation to show the sum of those three pieces equals 3/4. That leads me to our first vocab word today, unit fraction. A unit fraction is any fraction that has a numerator of 1. Okay, when we have just one piece out of the whole, no matter what size it is, we have a unit fraction. So we add up the unit fractions to get our 3/4. We're taking 3 out of the pieces, all of them divided by 4 pieces to equal 3/4. That's a unit fraction. This is some of the work that you guys did to have unit fractions that add up to a bigger fraction. So one of our classmates had a carrot garden as their fraction circle picture, and then they did 1/12 plus 1/12 plus 1/12 plus 1. They did it 6 times because they had 6 carrots to show that equals 6/12. They were even able to say that that's the same thing as 1/2. And 1/2 is the amount of a grass piece. So they said all of their carrots are equal to 1 grass piece. That was some really good fraction decomposition, what we're doing today. In this picture, your classmate has a yellow sun pieces that she's talking about, and that those equal 7/12 because she had 1, 2, 3, 4, 5, 6, 7 of them, and they were each 1/12. So you can see our unit fractions here added together to make the 7/12 there. So nice job. Those looked really great, guys. When we're decomposing a fraction, we're breaking it down into these smaller unit fractions or to smaller parts. Okay, so we're going to do all of these as sum of unit fractions. So if we're looking at 2/10, we would break that down as 1/10 plus 1/10. If we have 5/8, we're going to have 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. I have 5 of them to equal 5/8. 4/3, 1/3 plus 1/3 plus 1/3 plus 1/3. And you might be thinking that looks like more than a whole, and it is. And we'll get to some mixed numbers in a moment. And then 6/6 is equal to 1 whole. And we know that if we add up 1/6 6 times, we're going to end up with our whole, or 6/6. So that is writing our sum of unit fractions. We're decomposing and breaking it down into those unit fractions. Okay. I'm going to go back to my everyday math tools. I'm still looking at the red circle as the whole. And I want to use dark greens to show 4/5. So I'm going to pull open those tools and go back to my fraction circles, red whole, and I'm using this, break it apart to show 4/5. Here's 4 out of the 5 pieces, okay? See what the problem says? Write an equation. Oh, what fraction of the whole is 1 dark green? So when we're looking at 1 dark green, we can say it's 1 out of 5 pieces, so that is equal to 1/5. 1/5 is 1 dark green. How many dark greens do we need for 4/5? 4 of them. If we're writing an equation of unit fractions, that's our numerators are 1, then we have to do 1/5 plus 1/5 plus 1/5 plus 1/5 equals 4/5. So when we're using unit fractions, our numerators are all 1. Then it says, can we think of another way to decompose 4/5 as the sum of 2 or more fractions that have 5 as the denominator? So say we just had 2 fractions with 5 as the denominator, and we still want it to be 4/5. Couldn't I do 2/5 plus 2/5? Yeah. Or couldn't we do 3/5 plus 1/5 equals 4/5? Sure. These are no longer unit fractions because they don't have this one is. They don't have numerators of 1, but they are a decomposition. We're breaking 4/5 down into smaller chunks. If we look at that with our tool, we can still verify that we have, if we took 2 of these, made 2/5 plus 2/5, and put them together, we'd still get the 4/5 that we wanted. Or if I break them back apart and we have 3/5 plus 1/5, we're still going to get the 4/5. We're just thinking about breaking it down in different ways. Okay, going back. Now let's look at mixed numbers, decomposing the mixed number. When we think about a mixed number, that means we have a whole and a fraction combined. Okay, and so it's a fraction that's greater than 1 whole. So look at this picture here. Here's our 1 whole, but if we broke it down, it's really made up of 8/8 plus 3 more 8s. So I can think about this as 8/8 plus 3/8, okay? And that's the same thing as 1 whole plus 3/8. Decomposing that. So we can break it down even further. I can decompose 8/8 down into 5/8 plus 3/8. And then my 3/8 here, and that's going to give me still the 1 and 3/8. So we can break those numerators up as long as we're keeping our same denominator. So let's decompose some mixed numbers. If we have 1 and 3/5, remember we can think about this 1 whole as 5/5. So I could do 5/5 plus 3/5. We could break it down even further then, and we could say something like 4/5 plus 1/5 plus 3/5. And if we look at 5/5 plus 3/5 and realize that's really 8/5, we can think about how to break that down into different ones. 2 and 1/3. When we have 2 wholes here, that means we have 3/3 plus 3/3. There's 1 plus 1 plus 1/3. So we add all those up, we really have 7/3 here that we can decompose. So we could take it all the way down into 1/3, 1/3, plus 1/3, plus 1/3, plus 1/3, 2, 3, 4, third, one more is our 7/3. That's decomposing. Okay? All right. You are going to consider writing the sum of unit fractions, which is when we have 1 as our numerator, and we're just getting that many of the fraction. So in this case, we need 5 1/12ths, or in this one, we need 4 1/100ths to get the 4 hundredths all together. That's unit fractions. Or decomposing them down into just breaking into different parts. So 5/10 plus 2/10 is 7/10. This wants me to still do 7/10, but think about it in a different way. So maybe I'm going to do 1/10 plus 6/10. 1/10 plus 6/10 equals 7/10. Okay. If I did 7/10 in a different way, I could do 3/10 plus 4/10 equals 7/10. So I can do 3 of my pieces and 4 of them. And I'm still going to be covering the same amount. There's still just 3 pieces uncovered. That's decomposing them, not with unit fractions, but with just other parts. So you're going to practice today doing home link page 191, and please be sure that you complete all of them, but also that you do the multiplication at the bottom of the page too, and show your work how you solve those multiplication problems. Good luck, mathematicians.